collections in Java. Right. So before we even discuss what collections are and what the different types of collections are and what are the capabilities of collections, let's try and see why do we actually need collections at all at the first place, and what is the use of collections and what are the advantages of having collections. Okay, so here I've taken an example where I have a class of 6 students. Okay, and I've declared all student names for these 6 students. So my student 1 name is A, student 2 name is B, student C name is 3 name is C, and so on. So what I've done here is for 6 students I've taken 6 different variables and assigned values to them. So this was pretty simple, and it was not a lot of problem because this was only a class of 6 students. But let's say, for example, my class was having 100 students, then what would have happened? Will I simply write 100 different variables and assign 100 values to them for those 100 students? That would be pretty lousy code, right? It would be hard to write the code. It would take a lot of time. It would be hard to maintain such kind of code, right? So let's see what problems we have with this kind of design. The first thing is it's difficult to maintain multiple items of the same type. So if you see, all these 6 things are nothing but they belong to a same category of items. That's nothing but student names, right? So there is some way I should be able to group this category of items, and it's very difficult for me to maintain multiple items of the same type as different variables, right? The second problem I have with this kind of code is data manipulation issues, right? So let's say even I declared 100 student variables like this, and for instance, let's say that these are not student names but student roll numbers, and at some point, say for example, I need to rearrange these roll numbers again. They've got different roll number codes now. So would I again go and do this 100 times, write 100 lines of codes for simply reassigning the values of the student roll numbers? That would be a pretty tough and challenging job again, right? So I'll have data manipulation issues later down the road. And the third thing is I'm simply writing unnecessary code. So for something which I can complete in a few lines of code, I'm writing 100 lines of codes and increasing the complexity as well as quality as well as maintenance of the code. So someone down the future, if someone sees my code like this, it would be pretty tough for him to understand what's going on with so much code in my file, right? So these are the basic issues we have with writing such kind of code. So one solution to this would be, right, arrays, right? So we've already seen earlier that you can group multiple items of similar kind in arrays. So I can simply give have a string array called student name, and I can give all these 6 values in that string array, right? But now let's see what advantages I have with collections over arrays. So we've just discussed that collections are nothing but it stores multiple values of this similar kind in a single statement, right? And even arrays does the same thing. So what's the difference between arrays and collections? What advantages I have over arrays and collections? So it's actually not really correct to compare arrays with collections, but I'll just try and give an overall comparison between arrays and collections, because we've got different flavors of collections, and we cannot really compare each of this with arrays because they've got different functionality. But I'll just try to give an overall comparison on arrays and collections, what advantages and features we have in collections over arrays. So if you remember, in arrays we could only store items of a similar kind, right? So if I declare a string array, all I can put in that array is strings, right? If I try to put a number in a string array, it doesn't really work. So if I have a new integer array, I can only declare integers. If I have a string array, I can only declare strings, and so on. But when it comes to collections, I can have different types of items in a collection. I can declare a collection and I can store a string in the first position, I can store an integer in the second position, I can store an object in the third position, and so on and so forth, right? So there is no limitation to the type of element I am storing in the collection. So that's one of the difference. Now what's the second difference? Second difference is, in arrays the length is fixed. So if I declare an array of length 50, I can only use 50 elements, right? I can only add 50 elements to that array and not more than 50. And again, if I declare an array of size 50, it's going to allocate memory for me for those 50 elements in advance. So even though I don't use 50, I only use 5, I declare an array of size 50 and I use only 5, it's simply going to allocate space for 50 elements for me, which I'm not even using, right? So that's waste of memory, and also I won't be able to extend my array. But when you come to collections, there is no certain limit set for the number of elements you can add to a collection. You can add any number of elements to the collection, and you don't need to predefine the length of the number of elements you are going to store in that collection. So here, if you are using 5 elements in a collection, the amount of space that is taken on the memory is nothing but 5 space for 5 elements and not for 50 elements. So that's one of the difference between collections and integers. Number 3, when it comes to arrays, you will have to do all kind of manipulations yourself, right? So if you want to compare arrays or do anything, sort the array or a lot of other activities, you'll have to do all by yourself. But when it comes to collections, you've got a number of different methods which you are already provided with, and all you need to do is use those methods effectively to get the required functionality. So there's not much of effort from your end you need to do. So on an overall broad concept, this is the difference between arrays and collections. So further we'll be digging into all the different types of collections and their uses and different methods which you can use, which will give you a more clearer picture on collections. Okay, so this is the hierarchy of the collections. So we see here that map is doesn't really come under the collection hierarchy, but still it is part of collections overall. Okay, so under collection interface we have set and list, and we have different implementations for sets and lists. So we have hash set, linked hash set, tree set, and for linked list we have linked list, vector, array list, right? Similarly for maps we have got different implementations as well. So actually queues are also part of collections, but I have not added queues in this tutorial. So you would actually have queues as well here along with set and list. Okay, so as we've already seen, we have the 3 basic flavors of collections: lists, sets, and maps. So lists are nothing but list of things. So since as we've seen in the earlier example, we say we have a student class, student object with student name, roll number, and certain other attributes. So we can store a list of student objects in a list collection type, right? Similarly, sets are nothing but unique things. So sets are again nothing but lists of things, but these are lists of unique things. Okay, so basically if we are storing IDs, say for example, you need each ID to be unique, right? And you don't want any repetition or duplicates there. So for that kind of things you can go for sets, where you don't want any duplicates to be added to the collection. The third is maps, things with a unique ID. So we've said that sets are nothing but unique things again, and maps are also things with a unique ID. So what's the difference between maps and sets? When you come to map, it is actually a name value pair of implementation. So if you say I have a student object, so I can say that I store the student roll number, which is a unique key, as a name, right? So I can say name of the map is 1, and the value is the student object for roll number 1. Similarly, I can define different pairs of name value, right? So this is basically a name value pair kind of a implementation we have in maps, and not, it's just not a list of things. So that's the difference between maps and lists and sets in general. Okay, so these are the basic flavors of collections we have, and we have sub flavors as well, right? And the sub flavors are ordered and sorted, unsorted, and unordered. Yep. So when I say ordered, I mean that you can iterate over the collection in a specific order, right? So it can be the order in which you've added the attributes, or it might be some order, right? We will be discussing about that in detail in the future slides. And when I say sorted, I mean that the collection is sorted in a natural order. So if you are actually adding strings to a sorted set, it would store those elements in alphabetical order. So if I add A first, or if I add D first and C first, C second, and A first, A third, sorry, then it's going to store A first, C second, and D third, but not in the order in which I store them, right? So that is sorted. And again you have unsorted and unordered. All the implementations of lists are ordered, so that means you can iterate over the elements in a list in a specific order. And what this order is nothing but the based on index. So basically for all the list implementations, you can access the element based on the index of the element. So the index starts from 0 and it keeps increasing as you keep on adding elements. So you can access a particular element based on the index of that element in the list. Okay. So the first implementation of list is an array list. So this is nothing but a resizable array implementation of list. So when we discussed earlier that arrays, you need to specify a size for that array, but when it comes to lists, an array list, you don't need to specify a list size for that array list. It can be indefinite, right? And as we just discussed, it's ordered collection, and this should be considered when there are more data retrieval than add and delete. So this basically talks about between array list, vector, and linked list, when should you go for what type of implementation. So basically all the three are nothing but lists. So what is the criteria you need to employ when choosing the correct type of list implementation you need? So when there are a lot of retrievals than addition or deletion, you should go with an array list, because we know that array list is nothing but internally an implementation of arrays. So ultimately when you add elements to an array, it basically resizes the array and again tries to join the two separate arrays and does a lot of stuff internally. So that's not really the implementation you need to choose when you go for when you have more number of additions and deletions, especially when there is an addition or deletion in between the array, right? And if it's at the end of the array, it doesn't really matter a lot, right? So this is the criteria you need to choose array list for when there are more retrieval than add or delete. And the often used methods are add, get, remove, set, size, right? So they are really talk about themselves, so I don't really need to discuss more about those methods, right? Next, vector. So vector again is an ordered collection, since all the list implementations are ordered, and this needs to be considered when thread safety is a concern. So what does it mean? It means that vectors are synchronized. So all the methods in a vector are synchronized. So we will discuss the whole thing about synchronization and stuff when we discuss threads in the later part of the session. So but for now, you can just keep in mind that um, when you work with the multi-threaded environment, um, you need to go with vectors to provide thread safety, right? And again, the methods which are generally used are same as what we have in array list. Okay, and linked list is again an ordered collection, and this has basically faster insertion and deletion when compared to um, the lists, right? So when you have a lot of insertion or deletion to be done to a list, you need to use linked list, and when you have a lot of retrieval, you need to use array list, and when you have multi-threaded environment, you need to use vectors. So this is about the different implementations of lists we have out there. Next, set. So we've seen that sets are nothing but lists of unique items, right? So let's go ahead and so in sets you don't all the set implementations are not really ordered. So let's have a look at the different implementations we have. The first is hash set. So hash set is not ordered, not sorted, right? And it should be used only if the requirement is uniqueness. So the only requirement if you have is that all the elements in this particular group should be unique, you can go for sets, and you don't have any other complex requirements, simply go for sets, right? And the often methods used are adding an element to the set. Contains, this tells whether the particular element you are searching for contains does belong to that particular set or not, right? Remove and size. Okay. Next is hash set. So hash set is not sorted, but it is ordered. And what is the order criteria we have here? The criteria is nothing but the order in which the elements were added. So when you try to iterate over the hash set, linked hash set, the elements are retrieved in the order in which you added them, right? So that's the order we have in linked hash set. This is actually a subset of hash set, subclass of hash set, right? And this should be used when the order of elements is important to you. So if you say I've added element A first and then I've added element B, and while retrieving the set of elements I still want the same order to persist, then you should use linked hash set, right? So one thing about ordered and sorted is uh, implementation could be sorted, I'm sorry, it could be ordered, but yet it could be unsorted. So this is the case which I just told you. This is ordered, but it is still not sorted. But if an implementation is sorted, you can guarantee that it is ordered. So it can either be ordered and not sorted, or it can be not ordered and not sorted, or it can be sorted and ordered, but it can never be sorted and unordered. So that means if an implementation is sorted, for sure there's a guarantee that it is ordered as well, right? And the order would be a natural order there, right? Okay, the next implementation is tree set. So here is that just example which we just discussed. It is both sorted and ordered. And what is the order? So basically it's sorted based on the natural order. So when I say natural order, it means that if you are adding strings, it is sorted based on alphabetical order, right? But if you are adding objects to this tree set, how is it ordered? So basically then you implement a comparator where you override the compare to method, and in the compare to method you basically try to compare two elements based on some criteria. So let's say for example I have a student object in which I have a student ID and student name as attributes, and in the compare to method I will compare the student roll number. So I'll say that if student roll number of this object is greater than student roll number of this object, object 1 is greater than object 2, right? So that's the kind of comparison mechanism I use. So it's when you're using objects, it's totally up to you to define the uh, comparator and what's the order you want, on what's the criteria for ordering you need, right? Okay. And again, these are often use methods in a tree set, right? Okay, now coming to maps, as we've discussed earlier, maps is nothing but a name value pair kind of an implementation. So you give a name and then you give a value for that name, corresponding value for that name. So these are different implementations we have for a map. uh, Hash map is the first. It's not sorted and not ordered, right? And we can have one null key and a number of null values in a map. So we've talked earlier that map are again a list of unique IDs, right? So only the name in the name value part, only the name is unique and the value is, it's not required to be unique, right? So still all the elements are unique, you can even have null. So that means since there should be unique, you can have only one null value, right? So you can have one null key, but you can have a number of null values because the value part is not really unique. You can have duplicates. So this is not thread safe, so you cannot use this in a multi-threaded environment where you want to implement thread safety on hash maps, right? And often used methods are get, put, contains key, and key set in a hash map. So basically, when you say get, you pass the key for that, and you get the value for that particular key. So say for example, I've stored student IDs and student objects as name value pairs. So student ID would be say 1, and the corresponding student object would be stored in the value for that map, hash map implementation, right? So when I say get of 1, I'm going to get the value of the student object which is stored as a value for that student name 1, right? Next, hash table. Hash table is not sorted and not ordered again, but the difference between hash map and hash table is that you can have a null key in hash table, in hash map, but whereas in hash table you cannot have any null values, be it null keys or values. You cannot have any null items in a hash table. And hash table is thread safe, so that means all the methods in a hash table are synchronized. Okay. Linked hash map is not sorted and it's ordered, and tree map is sorted and ordered, and all the other features are same as what we have discussed earlier. Okay, so these are the basic implementations we have in collections.